Hello, everyone, and thanks for Vicky's introduction. And I want to introduce myself first. And my name is Zhou. Currently, I'm a postdoctoral researcher in School of Computing at Dublin City University. And today, the topic I will talk is multimedia retrieval in lifelogging. I think lifelogging, this concept, most people is not so familiar with it because it's not very popular to in public world. And because nowadays we have a lot of content, like our experience data, like phone data, or like work, like a MacBook, what you used and the time you used and what browser you used, and also like some feedback data. It's all sensor data recorded by digital device. And I think currently all this is based on Lifelog, because the definition of Lifelog, it is a form of PVC computing consisting of unified digital record of the totality of individual's experience. It is captured multimodally through digital sensor, like I showed in previous picture, and also like some feedback sensors, and store them permanently as a personal multimedia archive. That's Lifelog. So why we use that? Why we use Lifelog? Because the use Lifelog application we want to deploy, it is based on we want to offer a platform to help people to recall more memories from their previous record data or from their brain. Because like Lifelog data record, it includes some first view vision data. It includes some brain attention, hearing, speech, and biometric data we recorded. And all we want to extract from this a lot of data. What we want to get is the insight, how we can discover the insight in this data. After we get insight, we will just offer this to users to support their memory record. And because life experience data is huge, it's very huge archive. So we offer Lifelog. It is individual that have a platform for many aspects of like the experience. They have activities, experience, behavior, information, biometrics. This huge volume of data captured passively, you can see every day or timely, maybe some images captured per second. And then after they record it, they can submit or automatically submit to the platform. And the platform can help them to view them, and the users also can choose who or what they can access it. And the dataset currently we're connected, include some visual data. We use autographer or narrative to record image per 2 seconds. And also for activities, we use My App to record the location, the GPS data. And some biometric data includes the blood pressure or sugar, like blood sugar level. This dataset is also recorded by our Lifelogger. And some informations about the digital writing, and also like some music what Lifelogger listened to before. All these types of data are connected. And also based on the connected data set, we used some current state-of-the-art technical to extract the enhanced features, like some concept features extract from the images, and some like using some automatic speech recognition tools to extract the total speech conversation content inside. And also for some interaction, stress recognition. This is all we extracted as enhanced features. And here I list the structure of datasets we connected. And because a lifelog can end up looking something like this entire structure of XML files. And with continuous streaming of time-aligned multimodal data, you can see from this structure of the data, it includes image we captured, it include some categories or JSR or heart rate. This is all belongs to biometric data connected. And based on this data we connected, and here is the image. You can back to see we have the image path, and here is list six images, and our lifelogger use their narrative to record what they can see, and this record directly from first view. And after we get all the data, and we will choose some topic, like if you want to find the moment when the user, okay, it's me, when I has had a dinner with some people, or I have drink with some people in a bar. And this is a topic because we want this platform can help us to search this topic. And previous work, they have a lot of people work on some ACAF extraction or ACAF search platform, and all the data is offered is human, is manually on a manual annotation, and it's not automatically work. So, and from we start on the baseline of search engine, we want to change the manual work to automatic. And previous the baseline of search engine, we think is about we have a lot of raw data, and then we use different technologies to extract the features from them. And after we get the visual features or text features, and then we just map them in the data before database, store in database. And in database, we will index all the dataset installed inside. Then we offer an interface for some new users to extract or to search what they want to search. And here I list, on the right, they'll have a screenshot. It shows what tools we used for the object detection and object recognition. And this is because we use a Google class automatically records, just capture what the users, what the lifelogger can see. And then it automatically detect what exists in the screenshot, in the in the image from the glasses. And for on the left of this slide, it is entire of some challenge we joined, and because we have some workshop and we released some dataset, we released some topics, and there are some participants just join inside and use their automatic retrieval method to detect a result. And here is show, and there are some good results is over almost 0.5. And I also want to show you, and they also NTCIR-lifelog challenge page. Oh, I think that was a problem. I don't know why the browser can be opened. So the link I will ask Wiki to offer that published on the website. And because less of challenge is we want to more participants can join us, can just build their manually, build their automatically retrieval system, and using our public and free dataset. And from here, because we use some 2D, we use some browsers, web browsers to do search work. And also we use some VR technology to search lifelog images and lifelog some other metadata. And here display some work of our researcher did. It is using some VR technical. And they also have image and location time, and then save them to Elasticsearch, an API for some new users to use. And currently our work is all about web-based. It's on online platform to do that. And the technical we are use to extract some color and object and some OCR data from as a descriptor, and all images and also some metadata will save in the database as annotation of all the images and also metadata. And also, like if users type some text query in the search bar, it can directly encode the text query as embeddings, and then we see all the embeddings and some annotation in Elasticsearch. And after match that, we will return the dataset back to interface, and the other users or our Lifelogger can search and record their memory based on this platform and interface. And here I show a platform currently, it's not fully finished, but currently I can show the demo, tell you how to use this to search dataset stored in Lifelog. Oh, we just tested, but it has some problem with the link. And you will tell me when I can start.
Oh, you can do it now. We're all just live.
Oh,
live.
Great.
This is like after the talk, so this is like whatever you need to demo, it's fine.
Great. And because in my previous presentation, I don't know, horrible things happened. I can't click the link, can't open it. And now, okay, I try, because what I want to show always is that because the NTCIR-16 lifelog 4 task is ongoing. So, and we offer some data sets, and if you are from organization, and or you can organize just fill the organization grid form and also individual gradement form. And after you get account, you can download all these data sets. The link have published here. And the dataset includes some images and some metadata as I described in my slides. And it has some biometric data, has some activity data, and also has some audio data. And also they offer some visual concepts extract using bottom-up model. And if you also can extract visual features based on what model you will choose. Okay, this is the description of NTCIR-16, the website. And if you're interested in that, you can directly just register here. You also can contact me. And another one I want to show is a demo of currently the search engine built based on the Lifelog dataset. And currently, like you can just search like the topic we described, have drink in a bar, and then you can get all the images is related to the search topic, and can show a man is like have drinking a bar, and it's also on the up. On the top is show the event, because all the images is divide into different events based on the event segmentation. And also can screen see all the entire event from start and to the end. The person is having drinking in a bar, and and also like you can search any topic you want, and also you can see from the map, it will show where your activity part the most time he stayed. The user, not user, this Lifelog or user is stayed in Dublin. And also like if you can see in Dublin, most time in Dublin Center or sometimes in Lucan, it's just an entire map to navigate which most location the user was located. And this is just an entire platform help our Lifelogger and the user to record their memory. Yeah, that's all. I have finished the description of the website.